Here we have a bullet fired vertically upward from the roof of a 30-meter tall building and has an initial velocity of 120 meters per second. So this would give me initial, the magic word, means when time is 0, we get a conditioned t equals to 0, v equals to 120 meters per second. The acceleration due to free fall is given by this value, this expression. So let's look at A. Find the velocity of the bullet in terms of t. So given acceleration, we do know that in order to find velocity, we have to do an integration to acceleration with respect to time. So to integrate a constant negative 9.8, we put the variable t back plus an unknown constant k. We are given the boundary condition here. When time is 0, velocity is 120 meters per second. We substitute this in to help us obtain the value for k, and k happens to be 120. Therefore, we can answer the very first part. To find the velocity of the bullet in terms of t, v is given by negative 9.8 t plus 120. That's the answer for the first part. Hence, find the velocity of the bullet after 8 seconds. So when time is equals to 8, we can use this equation found in part A and substitute time equals to 8 and calculate velocity as 41.6 meters per second. Now let's take a look at part B. Now when the bullet reaches its maximum height, when is that going to happen? So we have a bullet shot from a building. It flies all the way up. At that very instant, this time that we want to find, the bullet actually stays stationary for that very second. So we want to find the time that happens. So in order for us to find maximum height, that would mean we will need to calculate when velocity is equals to 0. So since we have found from equation 1 the relationship between velocity and time, we substitute v equals to 0 and we can calculate when that happens. So time in this case is 12.2 seconds. So let's take a look now at part C. Let's do it here. Now find the maximum height reached by the bullet. So this bullet has actually been released from a building of height 30 meters. So we can take time to be 0, and if we take the ground as 0 displacement, 30 meters above that ground means s is 30. This bullet flies up. That instant when time is 12.2, it stays stationary before it falls back down again. So question now is asking us for that height, this particular s, this particular displacement that we need to find when that happens. So we need to find s. S, as we know, requires us to integrate velocity with respect to time. We have the relationship of velocity. So velocity is given by a negative 9.8 t plus 120 with respect to time. We integrate this and we get 9.8 t to the power of 2 over the new power. Integrate a constant 120. We put back the variable t plus k. We have this initial condition that we could use over here. So we plug it in and find our k in this case. So when s is a 30, t is 0. plus 0 plus k, we know that k is actually 30. So now we can actually find S to be given by the expression negative 4.9 t squared plus 120 t and k as calculated is 30. So when will this maximum happen? It happens when time is 12.2. So let's see if I can squeeze this in. 12.2 plus 30. You calculate and you obtain the answer given as above, 764.69 meters.